6-2, we're going to be multiplying polynomials. In day 2 of this lesson, we're going to do some binomial expansions that are raised to positive integers. So to multiply a polynomial by a monomial, we're just going to use the distributive property and our properties of exponents. Remember, when you multiply, you add exponents. Okay, so distribute, and you get 3x to the 5th, and then distribute 3 times 4 is 12x squared. Again, distributing, be a to the 4th b plus 3a squared b to the 3rd minus a b to the 4th. You should pause the video and try these two on your own so you're sure that you can multiply. Then check your answers. So how do you use the distributive property? Like in example 1a, you multiply each term in the polynomial by the monomial. How do you determine the sign of each term of a product? Well, you multiply 2 positives and you get a positive. And you multiply a positive and a negative, get a negative. Multiply 2 negatives, get a positive. When we're multiplying 2 polynomials, we can use the distributive property, multiply each term of the first polynomial to each term in the second polynomial. So, and there's 2 ways, well actually 3 ways that you can do this. The first way is multiplying horizontally, just like they have in that example above, where you take the x term of the first binomial, multiply it times each term of the second, and then take the second term and distribute that. And then, oops, I have something wrong here. Oh, this should be to the 3rd. Sorry. And then combine like terms, remembering to write it in standard form if you can. So there aren't any other x thirds. 3x squared plus 2x squared is 5x squared. 1x minus 6x is negative 5x. And there is only one constant. Vertically, you line them up. You want to put the greater polynomial first, and in standard form would be more helpful. And then it's like long multiplication, so you take negative 2, 1, and then negative 6x. And then the x times the 1, the x times and add the columns. So then you still get the same answer. Okay, I'm going to show you the table format when we find the product of two trinomials. So you take one of the two factors and you write it vertically, and then you take the other factor and write it across horizontally, and then you take the x squared times x squared, you get x to the fourth. 3x times x squared, you get 3x to the third. Negative 5x squared. Then x squared times negative x is negative x to the third. And then negative 3x squared. And then 5x. And then 1 times x squared, 3x minus 5. And then you can add on the diagonals. You see that they have the same exponents. So x to the fourth, and then 3x squared minus x squared is 2x, or to the third. Negative 5 minus 3 is negative 8, plus 1 is negative 7x squared. 5 plus 3 is 8, and then minus 5. Okay, so you have the outs. On the next page, find each product, whichever method you like to use. I suggest table format for the second one, but you can choose whichever method you like to do, and then come back and check the answers. Hopefully you got the same thing for that one. I don't have the answer on my notes, so I'm crossing my fingers that's right. What properties of exponents are used to multiply polynomials? And when you multiply, you add exponents. Okay. Okay, and then there's a nice little application here. Silva manages a manufacturing plant from 1990 through 2005. The number of units produced in thousands can be modeled by this function. The average cost per unit in dollars can be modeled by this function, where x is the number of years since 1990. Write a polynomial t of x that can be used to model Mr. Silva's total manufacturing cost. And the total cost is going to be the product of the number of units and the cost per unit. So we're basically going to multiply the two polynomials together. I think I'm going to do the table format again. Oh, sorry, I have a wrong exponent here. Oh, I forgot the x squared there. Okay, so this delightful mess is going to equal negative 0.123 4x to the fourth and I'm not sure if this is right either. I'm doing this in my head, so these numbers are not that great. Oops. So you get negative 0.008, 0.04, 0.032. Plus it's an ugly mess. And then we go to this one. What if the costs, what if the costs were changed and modeled by that function? let's do this the other way. So it's still going to be 0.02 x squared plus 0.02x plus 3. Your n of x is going to stay the same. Oh, it's just 0.2. I don't know. That could be a problem that I had with the other one. And this is negative 3 times 3 is 9. 0.6x and then negative 0.3x negative 0.02x squared. So I apologize in that last problem if I had the decimal wrong. And then we go here to negative 0.012x squared negative 0.008x to the third and point negative, let me get rid of that point, it won't let me. Right, I have to just write it over here. Point, we're going to have 1, 2, 3, 4, 5 places, so 4 zeros, and an 8 x to the fourth. So we get negative 4 zeros, 8x to the fourth, minus 0.006x to the third. And then we get negative 32 plus 6. 06 is, oh, I'm sorry, negative, 32. It's 0.032. So it's going to be plus 028 plus, x squared, and then plus 0.3x plus 9. Yes, a horrible mess, and I apologize. How do you know what operation is necessary? This word right here, cost per unit, lets me know that I need to multiply by units to equal cost. Okay, what a mess, but hopefully you're successful with a little bit easier ones, and that's the end of day 1.